Hi, everybody. My name is Sean Bouchard. You might know me from the Twitch show Mostly Walking with Day 9, or my own Twitch show, which is semi-weekly, called Play by Play, where I play video games and talk about experience design. I am an adjunct faculty at USC in the Interactive Media and Games department, the #1 games program in the country, in the US. We're very proud of that. And this is a lecture that I gave a couple of weeks ago as a guest lecture in a class for graduate students, where I had an opportunity to talk about spreadsheets, something that is very near and dear to my heart and my process as a game designer. And I am super pleased to share that with you today as part of Not GDC. So let's get started. Okay, this is a lecture called Structured Data, and it is about transformation of data through spreadsheets. So just to start off, I am a systems designer at heart. I talk a lot about experience design. I teach a lot about experience design. Experience design is obviously very important and core to the design principles of developing video games. But for me, systems are kind of how I see and think and relate to games. I think about games in terms of relationships between characters, between items and resources, between parts of the economy, parts of the mechanics, different elements. And in games, relationships can be expressed as numbers. So I think about games in terms of data. And in this talk, I'm going to invite you to do the same thing. Think about games in terms of data, because when you recognize that the world is data, you can do some really amazing things. And it's true, in games, everything can be reduced to data. Even sort of the visual elements of games are made up of points and vertices and polygons that are represented by numbers. And of course, as games become more complex, the data becomes more complicated, but it's still data. All of it, how things look, how things move, how they react to the player, how they interact with each other, what's easy and what's hard for the player to do, sort of core ideas of game design. As designers, we change the world by manipulating its data. And sometimes we have tools that help us do this, that help us represent the data that underlies our games in meaningful ways. And sometimes we don't have those tools, and we need to build those tools for ourselves, and that's where spreadsheets come in, because spreadsheets are really, really useful for building those sorts of tools that allow us to represent and manipulate data in a way that makes sense to us as humans and as designers, and then transform it into something that makes sense to computers. Spreadsheets are good for a lot of things. They're good for making lists and organizing tasks and sort of sharing who's doing what and that kind of stuff. Bug reports, contact information. Spreadsheets have a lot of uses, but what I'm going to sort of focus on today is a more advanced use of them, and that is this idea of transforming and creating a pipeline for transforming data from one mode, from one form, into another, to make it easier to manipulate that data for our games. So real quick, for those of you who are less familiar with using spreadsheets, and especially for using spreadsheets as more than just lists of things, I'm gonna try to keep this real brief, but a quick primer on using spreadsheets, some of sort of the mechanics of spreadsheets. And I'm going to use this as an example. This is a sheet for calculating hit points. You can see sort of I've laid it out in terms of the player level, and then at each level there's going to be some sort of incremental increase in hit points, and then we want to end up with a total number of hit points in the third column. So here's the first really important mechanic of spreadsheets, and that's this sort of autofill, autopopulate, drag to populate feature, which if you haven't used this, then you really haven't seen some of the cool stuff that spreadsheets can do, even for really simple use cases. And the way that this works is you highlight some series of numbers like this 1, 2, 3, and then you grab that sort of blue square corner and you drag it down, and the spreadsheet auto populates the sort of cells that you've dragged to based on the data that you started with. So it's counting from 1 to 9, and we did that just by dragging. We didn't have to actually type all of those numbers in. Typing the numbers 1 to 9 is not that hard, but when you have like really long stretches, this can be a real convenience. And as you'll see, we can do more complicated things too. So here, for example, in the change in HP, I want more hit points to be added at every level, and not just sort of like 1, 2, 3, 4. I actually want like 2, 4, 6, and I want that pattern to continue forward. So using the same technique, we can do that. We highlight those numbers, we drag them down, and you can see the spreadsheet's able to detect at least simple patterns and propagate using those patterns. And then the other thing that that makes spreadsheets really powerful is the way that you can use formula to populate cells. So in this case, for the total hit points, I want to take the previous total, in this case, the 10 that's directly above the cell that we're interested in, and then the change in hit points, which is directly to the left, and add them together and get a total, and that's the total HP for that level, right? You've probably seen this in spreadsheets. Cells are addressed as sort of a combination of letter and number. So C2 is column C and row 2, which in this case is the 10 directly above the cell that we're in. And then the cool thing that happens when you combine these two things together is that you can actually drag out and auto-populate cells with formula. So in this case, I've sort of typed in that one formula and I got the number 12, which is the number that I expected. But then I drag that down to populate the whole column, and in each cell, it now does that math for me. And you'll notice that in each cell, it actually changes the formula slightly so that it is always referring to the numbers that are directly above and directly to the left, which is exactly what I wanted to do. I wanted to take the total HP from the previous level and the change in HP from the left and add those together to get the new total. But those references are relative by default, which makes it really useful to be able to drag those formulas out and populate a bunch of cells. Okay, so that's the basics of like how we're using spreadsheets. And now I'm going to show you some real life examples of 3 sort of very different ways that I've used spreadsheets in my game development process, each of which uses some different types of formulas and spreadsheet features that I'll sort of point out and show you how they work. So the first one is laying out maps for a sort of game prototype called Minotaur that I worked on several years ago. Minotaur is this sort of weird prototype. It has not really gone anywhere. I haven't worked on it in a long time, but I spent a couple of weeks several years ago developing this thing in Unity that was basically just like it was a maze game at its heart. And you can see it's very related to Pac-Man. It's that sort of same basic mechanic of there is a maze and you have an avatar and you move through the maze. What's significant about this for our purposes is that the levels were generated from text files. So rather than like laying out each of the mazes in the Unity editor, I had the program read in a text file that represented that maze and that level, and then generate it for me, and that allowed me to sort of create levels and switch between them. And this was all on a path towards eventually doing procedural generation of levels. So level maps are constructed from blocks or tiles. So this image is kind of dark, but you can sort of see the like dark gray versus the black. The black passages have those dots in them, Pac-Man style, so you can kind of see things a little bit more clearly there. This is a 4x3 little rectangle of tiles. So the top row is wall, air, wall, wall, and then the second row is wall, air, 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 and then the third row is wall, 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 wall. It's just a wall. And then for convenience, I would represent those blocks, those tiles, by their initials. So W for wall, A for air. So this would actually be represented in like a text file as WAWW. WAAA, WWW. You can kind of see how that forms this like corridor bend that we see in the game when it's rendered. It's actually way worse than that, because like this kind of works for a 4x3 rectangle of the grid, but when you have a whole map that you want to display, it looks like this, which is just nonsensical. Like, this is purely nonsensical. It is really hard to understand. It's nearly impossible for a human to look at this and understand what the heck it means. But of course, the computer is going to read this in and do something with it, be able to sort of generate a level out of it, which is fine. But it means that if I want to make an adjustment to that level, I play the game and I say, oh no, there should be an extra wall here, or the passageway should connect, this way. If I have to go back to this block of text, that's awful, right? Like that's untenable. So here's how I solved this with spreadsheets, by creating sort of a spreadsheet page that looks like this, that was set up where each cell was more or less square, and I could sort of put all of the letters in them and use that cool autocomplete drag to populate sort of feature to drag walls out and drag corridors down where I wanted them. And it made it much easier to visualize what the map should look like. And so this was a way that I could sort of represent that data and easily make changes to it. If I wanted to open up a passageway, then I would just change some of these W's into A's, and that would do it. That's all I needed. This uses a feature of Spreadsheets called conditional formatting, which is unbelievably crazy useful in all kinds of contexts. Conditional formatting basically lets you change the color of the cell based on what its contents are. It allows you to draw attention to important data and keep things organized. It's rules-based, which means that it runs through a set of rules in order. And if you sort of use that cleverly, then you can do kind of complicated things with it. But you don't need to in order to just keep things organized. You can see the way that I have these rules laid out. It's just what color should the background be based on what letter is in the cell. So you can see that, like, if I go back to this slide, all I need to do is type out an A, replace a W with an A, and it'll turn light green, and visually at a glance, I can see that that has opened up a new passageway, right? And then on the second sheet of this spreadsheet, I had it concatenate all of those letters together to form these strings that then I could just copy and paste into my code and have the level generation system recognize and print out. So this is the formula that I use to do that: concatenate map A1 colon AX1. What the heck does any of that mean? Well, concatenate is a little bit straightforward. It just means like put everything together. So what's map exclamation point A1 colon, Z1 or AX1? There's two parts to this. The first is map exclamation point, which refers to a particular sheet by name. So in this case, my first sheet is called map. Map exclamation point means look at the map sheet. And then the second part, A1 colon Z1, is look at the range of cells between A1 and Z1. So in this case, it's all of the columns from A to Z, or from A to X1, or sorry, A to AX, in the first row, in that one row. And so we get something like this, where map A1 colon AX1 grabs the whole row from the visually laid out map spreadsheet and turns it into just a string of letters. And so you can see on this one, the first row is just obviously all walls because it's bordering the map, and it turns that into just a string of all of the walls. And then what I can do with this that's really convenient using that autopopulate is if I drag this down, then row 2 will grab map exclamation point A2 colon AX2, which is just the next row in the map sheet. And so this creates a pipeline that I'm able to use for transformation of data from a sort of visually laid out map that I have created that I can easily edit, that turns that into these set of text strings that then my game is set up to read in and use to generate the level. Transformation from human readable to machine readable. That's sort of what we're talking about. Okay, so here's example number 2. This is a completely different thing. This is laying out cards for a game called Nacho Chips. Nacho Chips is a dexterity card game. The premise is that it is a nacho party, and you have to enjoy the nachos more than anyone else at the nacho party. So that's sort of the goal and theme of the game. This is a game that I'm currently working on that I've been playtesting on and off for a little while. I playtest cards that I print out on sheets and cut into individual cards, and those sheets are printed out using Photoshop data sets. So Photoshop data sets, if you're not familiar, allow you to quickly replace elements in a Photoshop file. It works with text and image components, so you can replace sort of like a block of text, and you can replace individual images in your Photoshop file. It's great for laying out cards. That's what I use it for all the time, especially if they involve sort of lots of stats and a static overall design, which means that it's especially good for laying out sort of prototype cards that are maybe not the final layout, the final art, where you're going to want to like nudge things around to make them look really pretty on each individual card. But if you have a layout that is more static, where you can just sort of change the text or icons or things like that, this works really well. When you're doing something more production oriented, there are other tools that are better. So InDesign has functionality that's similar to this, that is probably just better in every respect, except that I am more familiar with Photoshop. It's easier for me to work in Photoshop, and so I tend to use the Photoshop data sets for when I'm doing prototypes of things. But all of these principles apply to InDesign and other programs as well. So the way you do this in Photoshop is you set up a Photoshop image file with swappable elements. You can see sort of all of the things in these two cards that are just swapped out of one and in the other. And then you define those elements as variables under the image menu. There's an option called variables. And then you import a data set as a separate file as tab separated values. So just a text file that contains tab separated values. And here you can see each of these rows represents a different card. And the score column at the beginning is the number, that number that appears in the center of the card, and then the 4 images that sort of go around that. If you look at these cards like this, right? The number in the middle and the 4 images around. So here's my spreadsheet where I have these laid out in a way that lets me sort of design and visualize them. And you can see it's actually very close to the final format, the tab separated values that Photoshop wants, except that this is a little bit prettier, easier to look at. I've got some color coding that happens, and I'm also not doing sort of the full file name. So if I go back up, this is the final format that Photoshop wants. It's got like a fully qualified file name for each of these images, and I'm just using the sort of the name of the thing that I want. I have a second sheet that is for tracking stats on those cards. So again, if I go back, you can see sort of like I've got jalapenos that are scattered through here, and I've got steak that is scattered through here. And at least, you know, when I'm starting out and I'm playtesting this first one, my goal is to have pretty even numbers for all of those different toppings spread out through all of the cards in the deck. So this is a second sheet that I have that uses this countif function, which I'm not going to go into, that basically just counts up the instances where that word appears in my set of data, and gives me a total, so I can see that like I have 9 jalapenos and 9 steak and only 8 salsa, but all of those numbers are pretty close to one another. I'm also using a conditional formatting rule here called color scale that makes it easy to highlight the differences between a range of numbers. So from 1 to 9, the lower the number, the sort of the lighter the color will be, and that helps visually sort of pick out things that are close together. All the 8s and 9s are very close together, and then these zeros, which are elements that I have cut out from a previous iteration of the game. There's no more beef, and so that number is 0, and that's very easy to see that there's just none of that. Okay, so my data includes sort of all of the toppings that I want on each one of the cards, and then to the right of that, in a separate column, in the G column, I have a bunch of static terms that I am going to reference later that allow me to construct those qualified file paths, the images / at the beginning and the .png at the end. And then my third sheet is sort of my output sheet, and this is where I do that. I sort of construct all of that stuff. So you can see that this does look like what Photoshop is looking for. It's got the fully qualified file paths for each of the images. And I'm using this formula in order to get that. This sort of like unpronounceable formula that's got the 3 parts separated by ampersands. Okay, so what does this formula mean? We know like the data exclamation point means that it's referring to a sheet called data. But what are these $signs? Well, the $signs allow you to specify like a static cell, a static column or a row, or in this case, because we've got $signs before each of them, a particular cell that isn't going to change. So when we auto-populate this formula through the whole list of all of the different rows, and it's referencing all of the different cards on our data list, on our data sheet, that initial term, which is images / and that last term, the suffix, the .png, those are not going to be defined relatively. Those are just always going to point at those particular cells. So the three terms, only that middle one is going to change row by row. And then the ampersands very simply just sort of append all of that data together. So that allows us to take sort of those three terms, the first one static, the second one variable, and then the third one, the .png, is also static, and put them all together into a single string that appears like this, which is exactly the form that we wanted the data in, that Photoshop wants the data in. And then in Google Sheets, you can go to File and download as tab separated values, and that creates a text file that is just exactly the form that Photoshop will import. So again, we've got this transformational process. And what's key about this is that we have the sort of like easy to understand, easy to look at initial sheet that's got all of these sort of color-coded values on cards that's very easy to make changes to make adjustments to. And because it's in a spreadsheet, it's easy to sort of see how those changes affect whatever statistics we want to gather on it, if that's something that we're interested in. And then it's very easy to sort of then export those changes into a new data set in the form that Photoshop will take in and turn into like a sheet full of all of the cards that you want. Okay, so here's my third example doing something completely different. This is making a scripting interface for a game called Cosmonet. Cosmonet is a game that actually just released, it just this week released on iOS, so you can go on your iPhone and search for Cosmonet and play this free little game. It is akin to a visual novel. It's sort of like a text-heavy narrative game. It's very short. It was created for the Global Game Jam 2018 by myself and my design partner and office mate, Marty Campos. It's about birds in space and taking personality quizzes, and it presents itself in these sort of like little instant messenger style text conversations. And one of the important things to sort of understand about this is that each of those conversations is linear, is just sort of like a linear set of dialogue. The game branches by deciding which conversations to show you, but within a conversation, there's no branching. So just to understand sort of the form of the game. Each of those conversations then is written as a text file that contains a sequence of commands. So just you can see, like, to receive a message from somebody on Earth through the text messenger, it would be something like these four commands. The first one shows the little typing animation, and then there's a 1 second delay, and then it changes that to the text of the message that you receive, and then there's another 1 second delay. And that sort of like sequence and those numbers can be adjusted to change the pacing of the conversation, but those are sort of like the standard. That's what 90% of the received messages look like. And then when you send a message back, most of the time it looks like this. There's a command that tells the system to wait for the player to hit the reply button. And then once they do that, it prints the sent message, and there's a 3 second delay. allow the player to sort of read that message. And again, like that can be adjusted for pacing, but this is just like the standard values. When we made this game, we actually wrote the script kind of more like you would write a script, with back and forth dialogue. And then I took that script and I manually turned it into this form where it sort of had all of these different commands and had values for standard values and sometimes adjusted values. But the script that ultimately goes into the game, this sequence of commands, is kind of difficult to read, and is really a pain to make changes to, because as you can see, like you have to really parse all of each of these sections of code to understand what's going on. The difference between a received message and a sent message is sort of like when it says received or sent, it's not easy to tell at a glance. So it's really hard to like do this writing or share this with a team that's doing script writing. So we wanted to create a tool that would make it easier to write and to understand and share and edit and iterate on these script files. And here's what I came up with. It's a little bit overwhelming. It's a little bit tricky to understand when you just glance at it, but it's actually much simpler than the sort of final text version. It's easier to compose dialogue like this, and I'm going to have you sort of focus in on just those two middle columns that are the messages back and forth. And if you do that, then you can see how this is sort of a much more human readable, sensible way to write and understand dialogue, right? It's messages on one side of a conversation and on the other side of the conversation. It's just this back and forth. And then what the system does is you simply write out text in this format, and it will auto-populate the default values for all of those other commands to the side. So it'll sort of create those values as you go, and then allow you to make changes to them if you want to change the pacing for this particular line. And this is using some sort of slightly more advanced logic in the formulas. So this is using an if statement to basically check, is the message on this line in column G on this particular row, is that blank? If it's blank, then don't put anything here. If it's not blank, then put a default value for the delay, which in this case is 1. And that if logic is really handy when you're trying to do something that's a little bit more advanced like this. It's very simple to understand the basic form of it. It's an if, and then inside of parentheses, 3 arguments. The first one is a condition, the thing that you're testing, whether or not it's true. And then there's a value if that's true and a value if that's false. Those conditions can include all kinds of things. Is a cell, this cell or some other cell, is it equal to a particular number? Is it greater than or less than a particular number? Is it equal to a letter or a string or a phrase? Or in this case, is it blank? You can sort of have different values be printed depending on that. And you can also nest these. So you can sort of have an if condition, and then if that's true, have another if statement that has different values based on some other condition. So again, we've got this transformation process where you go from a sort of human readable and more importantly, human editable version of the script, this back and forth dialogue, and a way of automatically, with very little human intervention, transforming that into a less readable but more machine-friendly form that the game is sort of apt to understand, is designed to understand, because it's simpler to program the game to understand it, so that the game can then generate content based on that. When you make adjustments, the game can very easily get a new set of data that incorporates those adjustments. So what I've done is I've created copies of these 3 spreadsheets, and they are online, publicly viewable at these URLs. If you care to see what the spreadsheets look like, how they're laid out, how the formulas work, if you want to mess around with them, then you are welcome to go to this URL and make a copy of the Google Doc, the Google spreadsheet, copy it to your own drive, and then you can make all kinds of changes and see what that does, experiment with it, and get a sense of that kind of thing. Yeah, so that's it. Thank you very much for listening to this. Thanks for giving me the opportunity to give this talk. This was a lot of fun. I hope that you learned a couple of things, or got a little bit of a different perspective on how some of these techniques can be used in different ways in the game development process. The gist of this, the thesis that I want to leave you with, is this idea that spreadsheets are really, really powerful tools that allow you to create pipelines for transforming data from some mode that is useful to you as a designer, that makes it particularly easy to visualize or to edit the underlying data that is interesting to the game. And then to take it through that pipeline and turn it into a form that is easier for the computer to understand, that can be fed into the game and actually worked with, turned into what it is that you're creating. So go play around with spreadsheets, see what they can do for you, see if this is useful, if this can sort of make it easier for you to create more complicated systems that have interesting sort of interrelationships, and iterate on those easily. Have a great week. Have a great not GDC, and I'll see you next time. All right, bye.